Chapter 18, Confidence Intervals for Proportions. So when we're working with confidence intervals, we're going to be working with a couple new calculations. The first here is the standard error, and that's the estimated standard deviation of the sampling distribution. And its notation is SE of p hat. And that's equal to the square root of p hat times q hat divided by n. The next component is the margin of error, which I abbreviate as ME. And that's equal to the z-score times the standard error of p hat. Now in the table below, I put some common confidence levels for confidence intervals. You can do a confidence interval at any confidence level, but these four tend to be the most popular ones, so I put those into a table here for you. So get familiar with those confidence levels and the corresponding z-score. So let's look at an example. We want to construct a 95% confidence interval for a p hat equal to 0.51 and a sample size of n equals 104. So the first thing that we want to do is we want to calculate our standard error of p hat. Now that's the p hat times q hat divided by n, and then we take the square root. So our p hat is 0.51. Our q hat is 1 minus p hat, which is going to be 0.49, and then our n equals 104. So we substitute those values into our equation, and that gives us a standard error of p hat of 0.049. Now the next thing that we want to do is we want to calculate our margin of error. And our margin of error is the extent of the interval on either side of the sample proportion. So our formula is the margin of error equals the z-score times the standard error of p hat. Well, the z-score associated with a 95% confidence interval is 1.96. So we multiply that by our 0.049, and that gives us a margin of error of 0.096. Now we want to construct the confidence interval. So we're doing the confidence interval around p hat. So the p hat that we have is 0.51. So we're going to plus or minus 0.096 from that 0.51. That gives us a confidence interval of 0.414 to 0.606. So that's our 95% confidence interval around a p hat of 0.51 and a sample size of 104. So what does 95% confidence really mean? Well, the formal version says 95% of samples of this size will produce confidence intervals that capture the true proportion. The short version, we are 95% confident that the true proportion lies in our interval. So remember, the p hat is a sample statistic, and the p, our true proportion, is the population parameter. So we're using our sample to come up with an interval as to what we believe the true proportion is. So if you were doing a 90% confidence interval, you would say we are 90% confident that the true proportion lies in our interval. So whatever level of confidence you are, that's the confidence interval that you're doing, so that would be the percentage that you would put into that sentence. So in order for this to work, once again, we have assumptions and conditions. So you should be familiar with these. We've talked about these a few times already. But we have our independence assumption, and that just says that the data must be independent. And in order to check that assumption, we have to look at our randomization condition and our 10% condition. We also have our sample size assumption, which is based on the central limit theorem. And in order to satisfy that assumption, we check our success-failure condition. Let's look at another example. In October 2015, the Gallup poll asked 1,015 randomly sampled adults the question, generally speaking, do you believe the death penalty is applied fairly or unfairly in this country today? 53% of those sampled answered fairly, 41% answered unfairly, and 6% answered don't know. So for this example, we'll treat those who answered fairly as a success and all other answers as a failure. Now, as a side note, the label success or failure does not equate to good or bad. So traditionally, what's labeled as a success is usually the outcome being counted. So for example, suppose we wanted to know the number of people in a sample who have a disease. Well, each person in the sample with the disease is counted a success, even though, I think we would all agree, having a disease is never good. Okay, so don't think that success failure is the equivalent of good and bad or positive and negative. That's not what it means. You're just labeling success to whatever outcome it is that you're counting. So our question is, from this survey, what can we conclude about the opinions of all adults? So the first thing that we have to do is check our assumptions and conditions. So let's look at our independence assumption. Our randomization condition, the problem tells us that the 1,015 people were randomly selected. So we've met our randomization condition. So our 10% condition, the sample is less than 10% of all adults in this country, so that meets our 10% condition, so our independence assumption is satisfied. Our next assumption is the sample size assumption, and we have to check our success failure condition. So our p hat is 0.53 and our q hat is 0.47. So if we take our n of 1,015 and multiply it by our p hat, that gives us 538. Our n times our q hat gives us 477. So both of those values are greater than or equal to 10, so our success failure condition has been met. So all assumptions and conditions are satisfied, and we can use the normal model to find a 1 proportion z-interval. So the next thing that we want to do is we want to calculate our standard error of p hat. So that's the square root of our p hat times q hat divided by n, and that gives us 0.016. So we're doing a 95% confidence interval, so our z is 1.96. So we calculate our margin of error is 1.96 times 0.016, and that gives us a 0.031. So our confidence interval is our p hat, the 0.53, plus or minus our margin of error, 0.031, and that gives us an interval of 0.499 to 0.561. Now we want to write a conclusion, and we want to write the conclusion in the context of the problem. So what we're going to write here is we are 95% confident that between 49.9% and 56.1% of all adults in this country think that the death penalty is applied fairly. So that conclusion is important. It has to be stated in the context of the problem. We're saying that we're 95% confident because we were doing a 95% confidence interval. So if you were doing a confidence interval of something different, like say 90% or 99%, that's what you would put in there. And then you're going to put your lower bound and your upper bound. In our case, it was 49.9% and 56.1%. Of all adults in this country, because if you look at the original question, they sampled all adults in this country. And then what are we talking about in this confidence interval? So the question was, do they think the death penalty is applied fairly? So all of that is in our conclusion. So it's very important that the conclusion is written in the context of the question that you are being asked.